Hello, good morning to all.
Good morning,
My
sir.
God, very good morning, very
Good
good
morning,
morning.
sir.
A very good morning, very good morning to all. How are you all?
Good, sir. How are you?
It's very cold here. I'm literally shivering, and my whole doors and windows are closed. Still, I'm shivering. Just give me a second. I'll wear one jacket. My God, it's like a cold wave outside the window. Just give me a second. These time I like to do hibernation. Just in the blanket and remain in the blanket. Food and everything should come on blanket like this. So I am wearing a t-shirt and then one jacket, then another jacket, which is a thick jacket. Right now, still I'm fearing. I know I'm having that cold issue. So yeah, good morning to all. How's Jawan? I'm feeling cold, and you are just telling me, sir. See, I have fan. What is this behavior? Huh? Yeah. Joshua, Sam, turn on the camera, please. Okay, so
Hi, I joined from Mumbai, sir. Internet is very laggy today. It's also feeling cold. The internet is feeling cold. No signal.
my God, Mumbai also have food. Okay, so Joshua, how's their weather?
It's pretty good.
It's
It's
cold.
sunny. It's pretty hot.
My God, my God, my God, my God. This is very thick jacket. Like those who just go and see that ice, no, like snow in Kashmir. They used to wear this type of jacket. Ah, okay. So what I was saying? I was saying that we were doing new chapter coordinate geometry. Okay, so we'll start that chapter. Coordinate geometry. Now, what do you mean by coordinate geometry? Okay, so coordinate geometry is basically uh, it's a graph part. So I ask you to bring the scale, pencil, eraser, sharpener, and the graph paper. Yes, everyone bought it. Yeah, welcome. So first of all, we'll understand through a graph paper. So just give me a second. I'll download the graph paper. Then I will let you know. Just give me a second. No? Okay. So you can see that this is a graph paper. Yes. Is it a graph paper? Yes, it's a graph paper. And in that graph paper is basically the small boxes are there. Okay. These small boxes are there. So basically, the graph paper in which the boxes are given. So these small boxes represent the equal length. Okay. For example, if this is 1 centimeter, this is also 1 centimeter. This is also 1 centimeter. So basically each side is basically one centimeter. Okay. Yes or no? So From our childhood times, we used to make graph paper like uh, uh, like this, no? Then like we are making bar graph like this. Yes. From our childhood time, we used to make like this. Yes or no? No. So basically, from our childhood time, this and this is called as y-axis, and this is called as x-axis. Okay. So, for example, this y-axis we used to write like a one. If I will leave one line, so this is called as one. Then I will leave one line, it is called as two. Then I will leave one line, then it is called as three. Then four. Then five. Then six. Then seven. Then eight. Then nine. Okay. So if you will read this graph, which graph? This graph, like this first bar. Okay. So you'll find it out that it went to 2.5. Yes. 2 and 3 middle, it's 2.5. So it went to 2.5. Yes. If you will check the second bar, it went to which? It went to till which? Can you tell me?
5. 5.
5. Yes. And if you will check the next one, it went to 6. So basically, this is all about why this which one bar graph, in which two axes we learnt about y-axis and x-axis. Understood, guys? No, still you didn't understand anything. Okay, but now here the things changes. Here, what we learn, it's bit totally different, but it's totally easy. Okay. So first of all, we should learn. Hannah, are you there? Turn on your camera, please.
Just 2 minutes, sir. Good morning.
Good morning. You're late. Okay. So what was I saying? Now the graph which we're going to learn, it's gonna be like this. Like this. Plus sign. Hospital sign. Yes. Is this graph easily you can see it? No. Can you see the graph easily?
Yes, sir.
Okay. So you can see that here we have plus sign. Here we have what? Plus sign in which this above axis is called as y-axis. This this right line is called as x-axis. This this is called as minus y-axis, and this is called as minus x-axis. Okay, understood? Yes or no? So it means that every time x-axis is also called as abscissa and y-axis is called as ordinate. X-axis is called as abscissa and y-axis is called as ordinate. Understood, guys? Did you understand? Okay. Now, for example, I'll do the numbering part. So this is called as 1, this is called as 2, this is called as 3, this is called as 4, then 5, then 6, oh, 2, -1, -2. Sam, are you getting it or not?
Yes, sir.
No?
I understand.
Okay. Okay. So like this you have to write. Like this you have to write in which x-axis, the plus positive x-axis, which is right side of the intersection. Okay, it's called as abscissa, plus x-axis, and minus x-axis is also called as abscissa. Okay, then like x-axis, positive or negative, it is called as abscissa. In y-axis, positive or negative, it's called as ordinate. Understood? Now, the intersection point. This intersection point is called as 0, comma 0. The intersection point is called as 0, comma 0, in which x-axis is also 0 and y-axis is also 0. Understood, guys? Yes or no? Okay. Now, okay. Now, how to write an address? How to write an address? That's the most important thing. Okay, for example, I put a mark here. So I will put a mark with a darker pen. So okay. For example, this is a point. Okay. So how will you write the mark? If I will say that what is the address of the brown point? What is the address of the brown point? So remember this thing. Every time we have to write the address is in the form of x comma 5. In which form? X comma 5. Every time we have to write this in the form of x comma 5. So for example, if I want to find the address of this, so on x-axis what is there? On x-axis 3.5. Yes. On x-axis 3.5, and on y-axis what is there? 4. So what is the address of this? So the address of this is 3.5 comma 4. Understood, guys? No. Hmm?
Can you repeat it again, sir? I didn't understand.
Yeah. I'll take one more example. I'll take one more example. For example, if I want to find the address of point, this point. So how will you find it? So if you will check it from the x-axis, first every time you have to check it with x-axis. So from x-axis is 3.5, which is coming this point, and the same from the y-axis it's 5.5 minus 5.5. So the address of this will be 3.5 comma minus 5.5. Sorry, like this. Did you understand, guys? No. Okay, we'll take one example. One more example. So, what is the address of this, Joshua? The pink one?
Sir, it's the Y is 4.5, right?
No,
Uh, so the Y is 4.5, right? Because it's in the middle of 4.
but it is lower than 4, na? If you will check, one,
Yeah.
2, 3, and the 4 is up.
Oh no,
It is lower than
3.5.
4. Yeah, 3.5. Yes.
And then minus 4.5.
Yeah, minus 4.5. So what will be the address of this?
Minus 4.5 comma uh, 4.5.
Yeah, good. Minus 4.5 comma 4.5. Did you understand, guys? Yes or no? Yes, Hannah.
It's 3.5, right, sir?
Oh, yeah, 3.5. What, Joshua? 3.5. Understood, guys? Yes or no? Okay, we'll take one more example. So, yeah. So, now what is the answer of this? I'll ask Sam. Sam will give me the answer of this. Sam, can you give me the answer of this? Sam, are you there?
Sir, -4 and -7. How do you say? Do you say
Yeah.
with the sign? Do you
Sorry?
say it with the do you say it like do you say it as -4 as well, or do you say the sign as well? Like
Yeah,
what
you will
sign
say
that?
sign also, like minus 4
Uh,
comma minus 7, like this.
uh,
Okay? Okay, so now I will ask Jahovan. Jahovan, can you tell me this, please?
4 comma
Sorry?
4 comma 0.
Yes, 4 comma 0. Why 4 comma 0? Because the x-axis is 4, but y-axis is 0. Yes or no? Okay, Abigail, can you tell me the answer of this?
0,4.
Yes, 0 comma 4. Why 0 comma 4? Because x-axis is 0, but y-axis is 4. Okay. Can you tell me the answer of this, Hannah?
0, comma -4.
Yes, 0 comma minus 4. So this is how we relocate the values of the coordinates. It's called as coordinates. Okay. And the plane, in the plane, like this whole plane in which we are making this, it's called as Cartesian plane. Which plane?
Cartesian.
Which plane? Yes, Cartesian plane. It's not Indigo plane. It's not Air India plane. It's Cartesian plane.
Sir, is
Okay.
that your own airline, sir? Is that your own airline, sir?
Yeah, it's Mets airline. Yeah, so Cartesian plane, okay, in which the whatever the graph work and we are making this plus sign and then we are allocating the coordinates, na. This is called as what? Cartesian plane. Which plane? Cartesian plane. Did you understand, guys? Yes. Okay. Now one more thing which I have to discuss. For that, just give me a second.
Sir,
Yes.
my graph paper looks a bit different.
Okay. What? Can you show me?
It's like this.
Yeah, it's okay. It's okay. The same thing is there. I have small boxes. You have big, like your graph paper is looking like this. Okay, just give me a second. Your graph paper is looking like this. This has one box and then another box like this. Otherwise it's same, like they have darkened the four square into one square like this. Otherwise it's same, no problem in that. Okay.
Okay, sir.
Okay, so what was I saying? Yeah, just give me a second. With different pen, I will take this pen. Okay. Now we can see that there are four sections are there. Like this is first, this is section, this is section, this is section, and this is section. So basically, this section is called as first quadrant. Quadrant. This is called as first quadrant. Okay. This is called as second quadrant. Okay. This is called as third quadrant. And this is called as fourth quadrant. This is called as four quadrant. Now, just tell me, like here, the x-axis is also positive and y-axis is also positive. So in first quadrant, the answer will come like positive, positive, like positive 3, comma positive 7, positive 9, comma positive 4, as like this it will come. Yes? Because x-axis is also positive and y-axis is also positive. Like whatever the number you can see, 3.5, like positive 3.5, comma positive 4, like this. In this, the answer, like in second quadrant, the answer is in the form of negative comma positive. Why negative comma positive? Because here x-axis is negative, but y-axis is positive. Do you understand? Yes or no? Okay. In third quadrant, what will be the then? Can you tell me? In third quadrant, what will be the like signs of the x-axis and y-axis?
It's common negative.
Negative, common, negative. Yes, good. Negative, common, negative. And in the fourth quadrant, it is positive, comma, negative. Positive, comma, negative. Did you understand, guys? Yes or no? Yeah, I'm giving you 4 minutes to quickly write it down, whatever they're telling you on the board. Oh my god. We'll do it. I'm coming in 4 minutes.
So what is the plane called? Quaternarian plane?
Cartesian. Cartesian.
Okay.
Okay, done. Shall I do this now? Okay. So now I will not use this graph paper. So I think you have got the idea how to use the graph paper. If the question comes in graph paper, I will take normally whiteboard. Okay. So now take out with me. Um. Okay. Okay. So who will mark it? So one by one, everyone will mark it. So A for Abigail. So Abigail, please mark the first one in the on the board. Just give me a second. I will allow you. Yeah. Now you can mark on the board. So can you mark it? Where to mark? Okay, minus 2 comma 1. Yeah. Next one, Hannah. Hannah, please mark it. Next, second one. Third one, Jehovan. Jehovan, third one, mark it. Fourth, Joshua. Joshua, fourth one is yours. And fifth, Sam. Sam, fifth, mark it. Write coordinates also. Wherever you're marking, write the coordinates also. Which you can write then it will be easy.
Sir, mine is fourth, right?
Yeah. Sam, are you there? Okay. Sam, fifth one. Okay. Wow, Johan. Good. Good, good. So everyone, I think, understood the concept of this graph. Yes or no? Yes. Then 19.1 is the homework. Okay. 19.1 is the homework, guys. You guys have 19.1 as a homework. Okay. The whole
Sir,
19.1 is yes.
what is it? Is it check your progress or exercise?
Check your progress. Exercise both are same, no?
Oh,
So check your progress 19.1, page number 499. 439, sorry. 439, check your progress 19.1 is your homework. So please do it. Can you write the quadrant also? In which quadrant you have found? So your respective thing. Can you write the quadrant also?
Sir,
Yeah.
I'm not able to type, so can I write the quadrant in the side?
Yeah, yeah. Hannah wrote, na? Hannah wrote.
Okay.
Who is missing? One, two, three. Okay, Sam. Sam.
Yeah, mine got deleted, sir. I wrote mine good.
Okay, okay, no problem.
So,
Yeah.
in check your progress 19.1, what
Mm-hmm.
one?
Huh?
How do we do the second one? The first and third.
Second one. Yeah, in the second one, it we can write 2 comma 4. Like for example, best example is Joshua 1. So you can see here that from y-axis, like from y-axis, what's the distance? From y-axis, what's the distance? 2. And from the x-axis, what's the distance?
6.
Minus 6. Right, this you have to write. It will check from the y-axis and x-axis.
It's the same of what's written, right?
Sorry.
The coordinates is actually the distance only.
Yeah. Basically, what is given? Like for example, we'll take this question, which is minus 7 comma 5. So from this y-axis, what's the distance? From the y-axis, the distance is -5, and from the x-axis, the distance is -7. This is a simple thing. Okay. So we'll stop here only. Tomorrow we'll learn about some formulas. Okay. Yes, Hannah. Hannah has one more time. Yeah.
I have a question about the TMA. So in the syllabus bifurcation, there's 60% which is the public examination which we finished, right? Do we also have to study the 40% of the TMA, or what we've done for the TMA, if there's only that much going to be asked?
TMA done. Done. TMA won't come in exams.
Of the other thing.
Sorry.
You don't have to do any of the 40%. Okay.
No. But if you want to read, then you can join with Abigail. Yeah. So yeah. So we'll stop here only. So I hope you enjoyed the class. We will have 4 minutes break, then come back in science class. Till then, bye.
Right, so thank you.
Bye bye.
Bye, sir. Thank you.
Thank you.
Wait, why am I saying bye? I'm going to be there for the science class.
Yeah. And one more thing, Jahoan, are you there?
Yes, sir.
I didn't get syllabus of science. Jahoan.
All the chapters that we didn't do, sir.
Yeah, which were left.
Okay, I got some of them. I'm not sure if it's all actually. We did not do
Okay,
chapter.
we'll do one thing. I'll take one name one by one. Okay, and then we'll check it out. Okay, you just tell me that we did or not. Okay. So just give me a second. Just give me a second. Okay, we'll check. Okay, so we did chapter number 5, atomic structure.
I think so. It,
Okay. Chapter number 6, periodic classification.
mm, I'm not
No.
sure which ones we did in module 2. I think I'm getting confused about chemistry chapters. I know we did not do anything in module 6. And
Okay, then
also
I will.
31 and
Uh,
32 we didn't do. 25 we didn't do. 19 and 20 and 17, 18, 12, 14, and 1. All of it's on 1.
okay. It means that we have to speed up in science. Yeah, we'll do it. Okay, guys, come back. Come back, come back, come back. Uh, Okay, so we were doing electricity chapter and we learned about the thing of ammeter, voltmeter. Everyone turn on the camera, please. Sam, Joshua, Abigail, please turn on the camera. Hello, Joshua. Good morning.
Good morning, sir.
A very good morning. So now today we will learn about the let me share. Now today we will learn about the cell. Basically, if I will in circuit diagram, if I will make a cell, the cell gonna look like this. This is called as one cell. Okay, in which the longer bar is called as positive terminal and the shortest bar is called as a negative terminal. Now, if one after one cell are connected to each other like this, if one after one cell are connected to each other then this makes battery. Okay, what's the difference between cells and battery? The combinations of cells, it's called as battery. The combinations of cells, one after one, is called as what? Battery. Understood, guys? No. Okay. So you can see that positive terminal and the negative terminal is there. Then the next cell, positive will connect to the negative. Understood? Like this, which makes battery. So in your clock, we are using cell, but in your remote, the TV remote, we are using battery. Understood? No. Why we are using battery? Because two cells are there. So two or more than two cells are there, then it is called as battery. Understood? So there's a difference between cells and a battery. Did you understand, guys? No. Okay. So now we will learn about two things which is called as conductor and insulator. Conductor and insulator. Just give me a second. We did all this part. Okay. Now the term is conductor and insulator. So from the word itself, we can understand conductor are those devices that conduct electricity. Those devices that conduct electricity are called as conductor, and those devices which doesn't conduct electricity are called as insulator. They will not conduct electricity. For example, if you will take iron nail and if you will take it to the switchboard, then you have a chance to meet Jesus. But when you will take plastic rod and when you will put it on the switchboard, you will not have a after some time you will have, but now you will not have. Why? Because the plastic is working as a insulator, but the iron nail is working as a conductor which conduct electricity from the electric board. It will come enter to your body and then you will have a breakdance. Understood, guys? Yes or no? Okay. Now we will learn about register. So before coming into register, we will understand first resistance. Okay. Now we can understand register also. So understand it like this. Okay. So please pay attention. Okay. Uh, I'll bring my charger. Let just give me a second. Okay. Now understand it like this, guys. Okay. This is my charger. Okay. If you will see, can you see the charger information? No. Is it blur? No. So if I will check and I will say my charger want only uh, input of, see, my charger takes input of 200 volt and gives output of 5 volt. Okay, so it means that the current which is coming, okay, my charger, what is my charger is doing, okay, uh, a huge amount of current is coming into the electricity board. But my mobile, which is connected to the charger, what charger is trying to doing that it reduce the amount of electricity current. So that if the same amount which is coming on the electric board, it goes into my electric current mobile, then it will blast because the charging needs less electricity. Understood? No, no, you didn't understand. We can take one more example, like geyser. Geyser needs huge amount of electricity to work, to heat the coil, to boil the water. But Same amount of electricity if this mobile takes, then what mobiles will do? Blast na. So there are some substances are there which reduce the flow of electric current, they are called as resistors. So resistors is like we can understand like this, like we have a pipe in which water used to flow through it. Okay, the water used to flow through it. Okay, resistors here are working like a pebbles. I made some pebbles. Now, if I will put pebbles, the water flow will become slow as compared to before. So resistors are the pebbles of the electric current, which works to reduce the flow of electric current, which reduce the flow of electric charges. And as the electric charges per unit time decreases, then electric current also decreases. Did you understand? Yes or no?
Can you say that again?
Can you see the last line again?
See, as what the pebbles are doing, they are interrupting the flow of water. Why? Because molecules of water is at like it's striking on the pebble and the flow of water reduces. Huh? So in the same way, when we are putting resistors are stopping the flow of charge per unit time. And what is charge per unit time? The flow of charge per unit time is what? Electric current. So as the charge stops or slows down flowing, then the electric current also decreases. Did you understand? Yes or no?
So
Everyone.
can you explain it again?
See, for example, this is flow of water. Now, if I will put a pebble in front of it, then what will happen? There will be problem in flowing of water. Understood? If I will put a pebble on it.
Yeah.
Why? Why? Because the molecules of water is striking on the pebble. So in the same way, the resistors are looking like a pebble. When you will put it, then the flow of electric current reduces. Why? Because the electric current is flow of charge per unit time. So the flow of charge per unit time is decreases. That's why the electric current decreases. Understood now?
Okay.
Okay. So we have done this topic also. Now we will understand a new law called as Ohm's law. Ohm's law. Okay. Now what is Ohm's law? Now everyone turn on the camera, please. Jehovah, please turn on the camera. Okay. Now Ohm's law says that. Okay. Now we'll take like this. For example, if I will take 2 volt battery, so it gives like current of uh, 2 ampere, for example, like 2 volt is the battery, volt, v, I learn a volt, and a is the current. So if I am giving 2 volt battery, it giving 2 current ampere. So for example, we can take one example. Okay, now if I will take 4 volt battery, if I am increasing the voltage of the battery, then what will happen to the current? It will decrease or it will increase? It will decrease or increase. If I am taking more powerful battery, okay, then what it will happen? Anybody?
It's supposed to increase, but the way you're forcing, I'm thinking it will decrease.
No, it will increase. It will increase only. Okay. So for example, uh, car battery. Okay, car battery. Now your clock need only a one cell, which is 2.5 volt, I guess, if I'm not wrong. Correct me and search at home and then tell me the answer tomorrow. So, for example, the clock wants only 2.5 volt, but our car battery is basically 12 volt. 12 volt. So, if I will attach my car battery to the clock, then what will happen? Then instrument in the clock, the machinery will burn because excessive current is coming. Why? Because excessive voltage battery gives excessive current. So if you will increase the voltage, for example, if you will take 6 volt, the same amount of current will increase in the same circuit, 8 volt, 8 ampere. So you can see that from this, what we can observe that V V is directly proportional to I. V is directly proportional to I. Means if you will increase the voltage, for example, in circuit, if you will increase the voltage, the same type of current will also increase. Why? Because V is directly proportional to I. V is voltage, where voltage of sources like battery or anything, and I is the current in circuit. I is the current in circuit. So voltage of sources is directly proportional to the current in circuit. So whatever the voltage you're providing, it directly proportional to the circuit, electric current. Understood? So if you will remove the proportionality sign, then you will find it out that V is equals to IR. V is equals to IR. Okay, where V is voltage, I is current, and R is resistance. Now, what do you mean by resistance? So, resistance is the property of a material to resist the flow of electric current. Now, understand it like this. No, don't write, Abigail. Just listen to me, okay? So, what is I'm saying? Resistance is the property of a material that wants to resist the flow of electric current. Now, we take example of conductor and insulator. Now, in conductor we take iron nail, and in insulator we take plastic. Now, why the plastic is not moving? Why the electric current is not moving through plastic? Why the electric current is not moving through plastic? Can anybody tell me why it's so? Because the electric current which is in the plastic is not able to move because of high resistance value of plastic. Now, now what does this mean? This means that if you will in a circuit, if you will increase the resistance, the current will decrease. They are both are like this. So we can also write like this: I is A proportional to R. One thing increases, another thing decreases. Means in a circuit, if you will put, for example, like this is circuit. We'll make one circuit. So, for example, in this 2 ampere current was flowing through it. Okay, no resistance was there. Okay, but now if if you will place a resistor sign is like this. Okay, so now what will happen because the resistor is there? Now the current will decreases of 1 ampere because of this resistor. This is called as R, which is resistor. And because of that, the bulb which was glowing brightly, now it will not that much brightly, it will glow. Understood? As compared to the first one, it was brightly, but now it's not brightly because the electric current flowing through the bulb is less. Understood? No. Did you understand the concept of resistance, guys? Yeah,
Yes.
quickly write it down. Quickly write it down. I'm giving you 2 minutes. Quickly write it down. Ohm's law states that the current flowing through a conductor is directly proportional to the potential difference applied across the end of a conductor. So, if the voltage, potential difference is basically the voltage, the potential difference is equals to V, na? So, the potential difference of the that thing is directly proportional to the current. Is directly proportional to the current. Understood, guys? Yes or no? Okay. Shall I use this? Okay. So yeah, resistance unit is basically ohm. So I will write resistance. The unit of resistance is ohm, which is also denoted by like this. So if I am writing 5 ohm, this is basically called as resistance, not nothing else, but it is called as resistance. Understood, guys? Write it down. So we got one formula which is V is equals to IR, where V is potential difference, I is electric current, and R is resistance. This is one formula which is very important. Understood, guys? Yes or no? Now write one question. I will tell you one question. If quickly write it down. If 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 10 if 10 volt current if 10 volt current no 10 volt sorry if 10 ampere current 10 ampere current is applied through a circuit having resistance 3 ohm, having resistance 3 ohm. I repeat it again. If 10 ampere current is applied through a circuit having resistance 3 ohm, calculate the potential difference across the circuit. Calculate the potential difference across the circuit. Calculate the potential difference across the circuit. Yeah. What's
Okay.
the answer?
Can you say the last part? Calculate the potential difference.
Across the circuit.
Okay.
Yeah, what's the answer of that?
So we have to use the formula, right?
Yes, we have to use a formula for that. No idea, Jawan? Yes, Jawan, no idea how to do this?
Won't that make V equal to 30?
Okay, what is I?
10.
What is R?
3.
Yes. So you have to multiply it become 30. Okay. So basically, the ampere represent current. Okay. So current is basically 5 ampere. The R represent like ohm represent resistance. Resistance is given basically 3 ohm, and this is 10 ampere. Sorry. So V is equals to IR. There is a formula. So V is equals to I, which is 10 into 3, which become 30 voltage. So potential difference across the circuit is 30 voltage. One more question, write it down. If the potential difference across the circuit, if the potential difference across the circuit, if the potential difference across the circuit is 220 volt, 220 volt, and and current current flows through it, current flows through it is 0.11 volt. 0.11 ampere, sorry. Che, what I'm saying. And the current flowing through it is 0.11 ampere. Calculate the resistance. Calculate the resistance. So yeah, how will you do just now? Yes, just now. How will you do this? Just are you there? Okay, you just unmute your mic and we will do it. No problem if you didn't understand. I will help you to do it.
I I didn't understand, sir.
So what is V? What is V in the question?
Volt
V means potential difference. Huh? How much?
potential difference.
Yeah, how much is there in the question?
220.
Yes, 220 volts. And what is I current? How much current is given?
0.11 amp. 0.11 amp.
0.11 amp. Now, what is the formula? V is equals to IR. Okay. So now we have to find R. So can I send I to the left hand side, which will become V upon I? Yes or no? Yes. Now V is given 220 upon I is given 0.11 is equals to R. Now this point will go and it will add two zeros because after point 2 is given, so that's why. Yes. So now 11 ones are 11 2. So the resistance which I got is 2000 ohm. Understood? 2000. Did you understand, guys? Yes or no? Abigail, do you get it?
Yes, sir.
Okay. So this is how we will do. Okay. So I'll give you some questions. Tomorrow we'll do the resistance of parallel and this. So write this down as homework. Example 16.3. Example 16.3. Okay. And this question 16.2, question number 6. 16.2, question number 6. 16.2, question number 6. Okay, we'll do till here only. So I hope you enjoyed the class. Till then, bye. Have a nice day. Signing off. Tata bye bye. Sayonara.
Thank you, sir. Bye.
Bye.
Thank you.